All right, so number 11, this is on lesson 6. Lesson 6. Example number 11, this is dealing with current sources. We have two current sources here. We have resistors. We're being asked to find I2, which is the current going through that 20 ohm resistor. And we're asked to find V3, which is the voltage across R3 right here. There's V3. But the first thing let's do, first let's look at what it is that we're trying to solve for. We're trying to solve for a current and a voltage. And the other thing is let's label nodes. And what we can see here is these are all between two nodes. Every single element here is completely in parallel with the other elements. If you're unclear on that, I can erase it and do the method where we go around. Follow it, only cross the wire whenever there's an element. Otherwise, just follow along the wire. In everything inside of my node, there are no elements, but everything that it bumps up against is an element. On the top, the same thing. Just pick anywhere, follow along the line, hit an element, turn around. Hit an element, turn around. Element, just follow the line, element. There we go. So everything's between these two elements. So one thing that we could say, just immediately that we can see, is that V3, right? That's the same voltage across anything. That's the same as the voltage across V2. That's the same as the voltage across V1. If we call this V1 and V2, they're all the same. They share the same two nodes on the outside, therefore they all have the same voltage. If I wanted to solve for V3 first, just knowing that I can combine these, 2 amps is going up, 6 amps is going down. 6 is greater than 2, so I'll follow it this way and say 6 minus 2 amps. I'm combining my parallel current sources. The other thing I can do is I can combine all my resistors. And I can put them into an R equivalent. That consists of 1 over 60 plus 1 over 20 plus 1 over 30. All of those go to the -1, which is like saying 1 divided by those sums. I put all of them together and I get 10 ohms. So now the voltage, now look at these nodes. When I combine these parallel elements, I kept the same nodes on the outside. If I called this A and I called this B, well, this is still A, this is still B. We're still looking at the same voltage across it. So if I had right here, this came out to 4 amps, and I wanted the voltage across it, well, we'll call this total now. I total, R total. The voltage, I total in this case is 4 amps. The R total is what we saw for right here, 10 ohms, and we get 40 volts. That's the V total, but that's the same as V3. Now for the other part, solving for I2, what's happened here is these 2 amps, or sorry, these 6 minus 2, the 4 amps, is my total amount of current that's being divided. And it's dividing itself into 3 different resistors. So if I wanted to be clear, it's that I have 3 resistors here, right? And then there's 4 amps going down. And it's dividing up, I'll put it in a light blue, it's dividing up here, here, and here. So I can use the current divider rule to solve for the current that I need, which is I2. Current divider rule, CDR. I recommend always writing your equation before you plug in any values, but we're solving for IX by plugging in I equivalent, R equivalent, Rx. That equation on the equation sheet is right here under current divider rule. My recommendation, always write down the formula before you plug in a value. So now I have these 3 parts. What I'm going to look for is I2. The I equivalent, there's 4 amps being shared. R equivalent is all 3 of those in parallel, which we already solved for, as 10 ohms. And then the Rx that I'm looking for is R2. R2 is 20 ohms. These ohms cancel out. 10 divided by 20 is 1/2, 4 amps. 4 amps times 1/2 comes out to 2 amps. And there is problem number 11.